All right, so our last section of Chapter 8, we are going to get into the world of simplifying radicals. Again, this sign here, the square root sign, is called the radical. All right, so now this, in order to do this, you have to have an idea of how to break 200 down into numbers that have perfect square parts, okay? What I mean by that, and if you want to set this up as like a factor tree, it might be helpful, okay? And not that it's exactly like a factor tree, but factor trees can help you. So what I look at this here is I'm going to look at 200, and again, that's where that chart of perfect squares may be helpful, is to go, okay, I want to break the square root of 200 down into smaller values, and I want at least one of those values to have a perfect square root, or to be a perfect square. So when I look at 200, I go, you know what? 200 is 100 times 2. Okay? Now in this particular case, though, because we have the radical, it's the square root of 100 times the square root of 2. Now I picked that particular number in this case because 100 I know has a perfect square. Okay, it is a perfect square. The square root of 100 is 10. Okay, now the square root of 2, well, 2 does not have a perfect square root, so we're going to leave that part. So again, I took the square root of 100 to get 10. I'm just going to tack on the square root of 2. So the simplified radical version of 200 is the square root of is 10 times the square root of 2. Now here's the thing. Some of these radicals have different ways in which you can break them down. Okay? But in either case, so let me go over here, and I'm going to do 200 again. All right? So I have the square root of 200 again, but I'm going to break it down in a different way. All right? So I know in this particular case, 200 is not only just 100 times 2. 200 divides by 25. Okay? And I say 25 because 25 has a perfect square root. That would leave me 8. So 25 times 8. Okay? Now here's the thing. And again, you notice this factor tree type of a thing. 25 does have a perfect square root of 5, which is all fine and dandy here and so on. But the thing about 8 is 8 itself, though, breaks down into the square root of 4 times the square root of 2. So what I'm at in this particular case, and maybe if you wanted this multiplication sign, you should keep it just to realize that we still have these parts multiplied together. So now when I get to this row here, this has a perfect square, so I will take it. All right, so now I have 2. I still have my square root of 2 over here. I still have my 5 that I have to break down. Well, now that I have these two numbers out of the radical, I can actually go ahead and put those back together. 5 times 2 is 10. Tack on my square root of 2. So you'll notice in each case, I got to 10 times the square root of 2. I just did them in a different order. So you have to be able to break these numbers down into perfect squares, perfect square parts, if they will. Okay? So 50, square root of 50. All right, well, 50 is pretty obviously 25 times 2. Okay, and again, so that would be the square root of 25 times the square root of 2. Well, the square root of 2 part, that's not going to go down any further, so I will just leave it square root of 2. Some people try to make this 1, and it's not 1. Okay, 1 times 1 is 1, not 2. Square root of 25 is 5, and so now I have 5 times the square root of 2. Now, other ways that you could break 50 down that do not help you is, yes, you could go 5 times 10. So square root of 5 times 10. But these do not break down themselves, so you don't want to do this way. This is a no-no. You want to break the 50 down into at least one value that is a perfect square, that does have a perfect square root. All right, 78. All right, so, and you may have to do a little guess and checking, and in some cases, it's possible that you may not be able to break a number down. So let's think about our perfect squares. All right, well, the square root of 1 is 1. That doesn't do us very good, or much good, right? So, and then, so our next one would be 2. Well, 2 times 2 is 4. So let's check, and I'm actually just going to punch this into a calculator. 78 divided by 4 doesn't happen evenly, so that doesn't do us any good, okay? If I go to 3, 3 times 3 is 9. All right, does 78 divide evenly by 9? Oh, sorry, 78 divided by 9 is 8.6 repeating. Well, that doesn't work either. All right, so we go to 4. That's 16. Does 78 divide evenly by 16? 4.875. That doesn't work either. 25 would be the next one. Okay, that would be 5. Well, 25 does not go into 78 evenly. Then we get into 6. Okay, 36. Does 78 divide by 36? The answer to that is no. And then after, well, we would have, I'll go over here, 49. And this is where your chart comes in handy. Again, I would have that chart filled out probably easily through the square root of 200. And then with some other possible additions in there. 78 divide by 49 evenly? No. Then we get to 64. Obviously 64 or 78 is not going to divide by 64. And so in this particular case, the simplified radical version of the square root of 78 is the square root of 78. It is not going to break down by perfect squares, so it will not go any further. So we have the solution already. We're not going any further. But again, having your chart to use will be helpful in simplifying radicals. So the square root of 32. All right, here, I'm going to flip back. 32 obviously divides by 16, so I'm going to use the square root of 16 to my advantage. And I am going to go the square root of 16 times the square root of 2. The square root of 16, well, that is 4. And then tack on my square root of 2, and we're done there. Now, if you want an alternate method, let's try something else. Here, I'll go over here, square root of 32. Let's say you went 8 times 4. So the square root of 8 times the square root of 4 is how you choose to break it down. All right, fine. Well, the square root of 4 we know is 2. And that will, now I'm taking the square root, so this is just a 2. But 8 breaks down into the square root of 4 times the square root of 2. Well, the square root of 4 is 2. Not going to take the square root of 2 because it doesn't go further. And then we'll bring down our other 2 here. And now we can go ahead and bring this 2 and that 2 there back together. 2 times 2 is 4. And tack on our square root of 2. So either way we get there. It just depends on which method you use. But in either case, you'll notice we broke 32 down into at least something that had a perfect square root to begin with. And then we went further, realizing 8 also broke down into something that has a perfect square. All right, the only way to get good at practice, to learn mathematics, is to do mathematics. Your job, go do some mathematics. Come see me for help.